Salam and hello everyone. We are asked this question. A gas mixture consists of 320 milligrams of methane, 175 milligrams of argon, and 225 milligrams of neon. So we're going to break this down because that's the first thing you do anytime you're given a question in physical chemistry or thermodynamics. It's best for you to like put down all the parameters you're given step by step. So we're told 320 milligrams of methane, which is the same thing as CH4. Well, because usually we deal with grams in chemistry, we're going to convert this from milligrams to grams. It's important for you to know that milligrams is the same thing as times 10 raised to the power negative 3 grams. So this means we're going to push the decimal point 320.0, this one, three times to the left in order for us to convert from milligrams to grams. So this 320 milligrams is the same thing as saying 0.320 grams of CH4. Okay. Now we also have the next one, which is 0.175 grams of argon, which is the same thing as 175 milligrams, and then 0.225 grams of neon. So having this information down is critical. The next thing we have to understand is that we are told the pressure of neon, which is pressure of neon is 8.87 kilo Pascal, right? That's the thing that you've told us. It's important for you to know that this particular question is dealing with Dalton's law of partial pressures, where the total pressure of a mixture is equivalent to the pressure of is equivalent to the total of the pressure of each individual gas in the mixture, right? So you have 8.87 kilopascal. Now we only know the pressure of neon because this is a gas mixture. So anytime that you're dealing with a gas mixture, and you have different gas components in the mixture, you have to understand that the pressure that each one of the gases will exert would be different, right? Except if the question tells you otherwise that it's the same exact pressure. So the total pressure is not going to be just the pressure of one gas, it's going to be the pressure of every single gas. So this is 8.87 kilopascal. So this is just the pressure of neon. But then they mentioned the pressure of neon at 300K. Well, 300K is us them telling us that the temperature of the mixture is 300 kelvins. Now, I wanted to mention that I'm sorry, this temperature is not the temperature for just neon. This is the temperature of the entire mixture, meaning the temperature of 300K is going to affect both methane, argon, and neon, not just neon. They just kind of wrote the question in a way that makes it look like the temperature for neon is going to be different for the temperature for methane and argon. No, it's like you boiling water and they tell you the temperature of water is this. Water is consists of H2O. Yeah, and they're not going to tell you the temperature of one hydrogen or one of the two hydrogen atoms in the water molecule is 300K, and then the oxygen is 600K. The entire temperature of the mixture is, for example, 300K. I'm only using this to denote, it's just to tell you that the temperature of the mixture is going to be the same regardless of the number of different gas components in the mixture. So this temperature is the temperature for every single component in this gas mixture. So we have the temperature now, we have the pressure for neon, we have the mass of everything. Now we're asked to determine the volume as well as the total pressure, which is P tot of the mixture. That's what this question is asking us to do. Now, the first thing you have to do is anytime you're asked to find the volume, we will go back to our understanding of the perfect gas formula, which is PV equals to nRT. We've been given the temperature, so that is good. We know what the gas constant is going to be because it's a constant. We know the pressure of just one component. Now we're going to be wondering, how do we solve this? Well, it's important for you to know that whenever you're dealing with whenever you're dealing with mixtures with multiple gases, the number of mole that one gas component exerts is different from the number of mole that the other in the mixture exerts. Now we have three different ones. We have methane, argon, and neon. It has to tell you that the number of moles of methane, right, N of CH4 is going to be different from the number of moles of argon in the mixture, right? And the number of moles of neon would be different. So it's not only the pressure that is affected, the number of moles is also going to be affected. Meaning the volume, the gas constant, the temperature are the only things that would be consistent regardless of the mixture. They're going to be the same. So when we calculate the volume is not going to be separate for each one of the different components. It's just going to be one volume, one temperature, one gas constant. But pressure that will be exerted because of the number of the mass of the gas is different. The pressure would be different, and also the number of moles would be different. So we've been given just the number of moles. We've been given just the pressure of um what's it called, the pressure of neon. So we're gonna have to use the number of moles of neon to solve this. So this is gonna be the pressure of neon is gonna what we will use times the volume equals the number of moles of neon times r times t. So to find the volume, we end up writing this in terms of volume. So we have the number of moles of neon times r times t divided by the pressure of neon. So this is going to be number of moles of neon. We already know that 0.225 grams of neon. So in chemistry, basic chemistry, we know that number of moles is always going to equal of a gas or of anything, of an element, an atom, all of that. Number of moles is always going to be the mass over the molar mass. We have the mass of neon to be 0.225 grams, and we have the molar mass of neon to be, even though we don't have this information on the screen, you can just Google it, which is what I'm going to do, or you can use your periodic table. So the molar mass of neon is 20.18 gram per mole. So we insert this in a calculator, we cancel out the grams, and we would insert this information in a calculator to get B 0.11150 mole. So we've determined the number of moles of neon. Now we can input this information into the calculation. So that's going to be volume equals number of moles of neon will be 0.11150 mole times r. The r that we need, the gas constant we need, is going to be determined by whatever the units are. So we have mole unit, we have Kelvin unit, and we have the volume. We've not determined the volume, but we have our pressure in kilopascal. So what we're going to be using is the gas constant 8.3145. Okay, kilopascal liter divided by mole Kelvin. So that is what we're going to be using. This is gas constant because we also have the gas constant 0.08206. That one works whenever we're doing liters, atmosphere divided by mole Kelvin. In this case, we're dealing with kilopascal, so the gas constant is going to be different. So we only have two gas constants, and that's determined by the units that we're given in the question. So in this case, we're going to use 8.3145. Okay, 8.3145 kilopascal times liters divided by mole Kelvin. And then lastly, times, we've got number of moles R, and we've got temperature, which is 300 Kelvin. All of that information divided by pressure, which is 8.87 kilopascal. So we're going to cancel this out. We're going to cancel out the moles. We're going to cancel out the Kelvin units. We're going to cancel out the kilopascal. And what we're going to end up with is just information involving volume. So volume is going to be all of this information inputted in a calculator. So we have 0.1150 times 8. Please do it with in your calculator as well. 8.3145 times 300 Kelvin divided by 8.87 kilopascal. So that's going to be 3.13542 liters, which you would do the sig figs, since we've been given everything in three sig figs. So the volume is going to be 3.14 liters. So we've been able to do half the question. Now we're going to go to the total pressure of the mixture. Well, if you remember, I told you Dalton's law of partial pressures. We're going to have to determine the pressure of methane, okay, as well as the pressure for argon in order for us to be able to determine the total pressure. So when we determine the pressure for methane, the pressure for argon, and we've been given the pressure of neon, we can add them up to determine the total pressure. So the next thing we're going to do is let's determine the pressure for methane. So the pressure for CH4 is going to simply be what we know is going to be this times the volume using the perfect gas law equals the number of moles for the methane gas times R times T. So determining the pressure would just be P, the pressure of methane equals the number of moles of CH4. We're just doing everything in terms of pressure of methane times R times T divided by volume. We've determined what the volume is. So we have the pressure of CH4 to be number of moles of CH4. We're going to do the exact same thing, right? We know we have to determine the mass. That's going to be the mass of CH4 divided by the molar mass of CH4. Okay, times R times T, all of that information divided by the volume. So that's what you're going to do here. And when we do that, we will end up with, let me draw something that separates it. So the pressure of CH4. Make this a little bit smaller and we can focus on this part of the work. So we have the mass of CH4. We've determined it over here. Oh no, we've been given it over here to be 0.320 grams. So that would be 0.320 grams divided by the molar mass of methane. You can Google what that is online. So molar mass of CH4, which is methane, that would be 16.04 gram per mole divided by 16.04 gram per mole. Okay, times R, which is simply 8.3145 kilopascal times liters divided by mole Kelvin times the temperature, which is 300 Kelvin. All of that information divided by volume. Let us use the volume without the three sig figs in order for us to maximize the calculation. So we have 3.13542. It's not good for you to use the estimated value of things to do further solution. You can only like give the estimate of use, you can only like give the estimate of something after you've done all the calculation, if that makes any sense. So we've got grams. We're going to cancel our grams. We're going to cancel out the liters. We're going to cancel out the Kelvin. And we're going to cancel out the mole because we're trying to find pressure. So all our answer has to be in kilopascal. So when you do this pressure here, we're going to the pressure of CH4, we're going to now go on to write E 15.871 kilopascal, which is the three sig figs of this is going to simply be put here. So the pressure of methane gas is going to be 15.9 kilopascal. So we've gotten the pressure of methane gas. The next thing we're going to do is to determine the pressure of the third one, which is argon. So I'm just going to take this up a little bit. So the pressure of argon would be pressure of argon equals the number of moles of argon times R times T divided by the volume. So the pressure of argon would be, for us to do this, the number of moles, the mass of argon that we're given. Just basically what we did for CH4 methane, we're going to do it here, times divided by the molar mass of argon that we're given. So just a repetition of what was above, times R times T divided by the volume. Number of the mass of argon, we have that to be 0.175. I'm sorry, 0.175 of argon. So that would be 0.175 grams divided by the molar mass of argon. That's 39.948 gram per mole times the gas constant 8.3145 kilopascal times liters divided by mole Kelvin times 300 K divided by volume, which is 3.1354 liters. So you cancel that out. So you cancel grams, you cancel grams, you cancel mole, you cancel mole, cancel Kelvin, you cancel Kelvin, you cancel liters, you cancel liters. So what you end up with is, so you input all of this information to the calculator, and that's what I'm trying to do. So what you end up with is 3.4850 kilopascal. So that is what you get as the pressure of argon. So now the total pressure of this is going to be the pressure of argon plus the pressure of methane, CH4, plus the pressure of our beloved neon. Is when we add all of this up, we're going to get the total pressure. So this would be, total pressure would be 3.4850 kilopascal plus the pressure of CH4 15.9, sorry, 15.871 kilopascal, because it's wise for you to always use the unapproximated or unestimated version, not before doing your calculations. You can only use like you can only use that to find the proper estimate, so you don't end up making mistake in your work. So plus 15 point, sorry, plus 15.871 kilopascal plus the pressure of neon, which was given to us in our question to be 8.87 kilopascal. So we put that down because that's what we're given, 8.87 kilopascal. Then you add all of this information up to get 28.226 kilopascal, which we would do the sig figs for to be 28.2 kilopascal at three significant figures, because that's where all our questions, how our questions has been given. So the total pressure is 28.2 kilopascal. So please look at your work and look at everything we've done. We've been able to successfully determine the volume at the beginning, which is 3.14 liters, and we've done the work to get it. We first of all went to use our we first of all determined the volume by using the pressure that we were given and the number of moles that we were given, or the number of what the mass that we were given. We used to determine the number of moles, and we put that into the gas equation, and we determined the volume of the entire mixture because we used the pressure of neon that we're given. Then when we determined the volume, we used the volume to determine each one of the pressure in the mixture. We determined the methane gas pressure, and we also went on to determine the argon mixture. When we had all three of this information, we're able to add each one of the individual pressure to get the total pressure. This question is a perfect application of Dalton's law of partial pressure. Hopefully, I've been able to successfully teach you guys. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.